Hello everyone, welcome to another video. So this is part 3 of Docker for DevOps crash course. If you have not watched part 1 and part 2, I highly recommend that you watch those two videos first and then come back to this one. In this way you will be able to understand all the concepts in a better way. Anyways, so today I'll be talking about Docker storage and Docker networks. And I'll start with some of the basic concepts around how storage in Docker works. So on my screen, you can see I have a Docker host. Docker host is a machine where you install Docker. On my machine, I have a container. Okay, so let's just talk about a few storage concepts around Docker container and Docker image. So by default, whenever you create any Docker image, the image is a composition of multiple layers stacked upon each other. These layers are representing the different instructions that you must have provided when you created the Docker file, which forms the basis of a Docker image. Okay, so as you can see here in this diagram, this portion here till here is the Docker image. Okay, so when you create a container from a Docker image, Docker just adds up another layer on top of your Docker image. This layer is called container layer. Okay, so this is my entire container, but actually what happens, Docker just adds another layer on top of your Docker image, and also by default whatever data you write in this container layer is going to get lost if you terminate or delete the container. Okay, if I talk about the concepts around image, each Docker image that you create is immutable, which means that once the image is created, it cannot be changed. It can only be changed when you create another image using the previous image and you add another layer to it. Okay, so that's the only scenario where the image layers can change. Else these all image layers are read-only image layers. As you can see till here, this is the Docker image and each layer is a read-only image layer. You cannot make any changes to it. Fine. And by default, when you are creating a container from a Docker image, okay, as I mentioned, one container layer is added to your Docker image, and whatever data that you create inside this container, okay, if it's your application that is creating some data, or you have logged into your container using docker exec command and then you are trying to create some data, whatever data is there inside your container, when the container is deleted or terminated, that data is going to get lost. So this is the default behavior of a container. Okay, so by default, the Docker containers cannot persist data inside them. Okay. Now another concept that I want to talk about, and it is often asked in the interviews as well. Suppose this Docker image has some file in it. Okay, so when you created this Docker image, it has a file in it. So when you are creating the container from this Docker image, and when you are trying to make any changes to this file which was part of the Docker image, at that time what happens, since our Docker image is immutable, it cannot change. So what it does, it just creates another copy of that same file and puts it in the container layer. So now any changes that you make is going to be made on that copied file in the container layer, and the original file which is part of the Docker image is going to remain as it is. Since these layers are only read-only, we cannot make any changes. But if any files are being modified in the container layer, okay, or when you are working with the container, then that file will be copied to the container layer and all the changes will be made to this copied file. This principle is called copy on write principle. Sometimes it's called COW, or some people also call it cow principle, COW principle. Okay, so it's called copy on write. Okay, so this is how the storage works by default in a Docker container. Also, whatever storage, whatever image layers are being created, okay, and whatever container layers are being created, all these different layers of image and container are being managed by storage drivers. So Docker has some storage drivers by which it is able to manage all these image layers and container layers and all the data within the container layer and the image layer. Okay, if I talk about a few storage drivers, so storage drivers is like, suppose you have some specific use case for your container where you want some really high performance of your storage, so you can use a better storage driver in that case to have that type of performance. So it really depends on what do you want in your container. So you can use different type of storage drivers. Okay, so here I am on the official documentation of Docker where they have spoken about storage drivers, and on the left hand side you can see the different types of storage drivers like BTRFS, device mapper, overlay, ZFS. So all these are different type of storage drivers, and these are the main drivers which are managing all the image layers and container layers in Docker. Okay, I hope this concept is clear to you. Then next I want to talk about how we can persist the data inside a container. So as I mentioned, by default all the data within this container layer or within the container that you are working with is going to get lost when the container is terminated or deleted. And also the containers are ephemeral in nature, which means that they keep crashing. Okay, and then we can create a new one, but our data should not be lost. So there are some cases wherein we want to have this data persisted on a disk. Okay, for example, when you're creating a database container, if you have a database which is deployed as a Docker container, in that case you would want to have that access to the data even though the containers are deleted or terminated. Okay, so to persist the data in a Docker container, we can use the concept of Docker volumes. So Docker volumes is a way by which we can persist the data inside the container. Okay, so in this diagram itself, if you see what happens if you create your container using docker run command, and if you use an additional flag -v stands for volume mapping. So here what I'm trying to do here is I'm trying to use a volume called volume1, and then I'm trying to map this volume1 inside the container. So this first value volume1 is the location of my data on my Docker host. Okay, so I'm trying to map this volume on my Docker host to inside the container on this location /var/www/html. Okay, and then the image name. So what this will do, when you create a container using this command, when you are using this -v flag, what it's going to do by default on Docker host, when you install Docker, under /var/lib/docker/volumes. Okay, so this is the location where this volume will be created like this. Okay, so after I run this command, if this volume1 is not created, okay, Docker is going to create this automatically for me. Or you can create this volume using Docker create volume command as well beforehand and then use it here. It's up to you. If you don't create it, it's going to get created automatically by Docker anyways in this location as I just mentioned. Okay, after this is created, then under this you will see a directory called /data, and this is going to hold all your data, okay, that you create inside the container. So if it's your application that is creating some data after you have created this Docker container using this command with -v flag, or if you have exec, if you are logging into your container using Docker exec command, so whatever changes you make, whatever data you produce, okay, it can be that you're trying to modify an existing file which was in the Docker image, or you're trying to create new files. All those files will be created under this location on your Docker host. Okay, so even though it will feel like that you are creating the data inside the container, but the data is going to persist on this location. So if this container gets deleted or terminated, you still have your data saved in this location on the Docker host. So this is the way by which you can persist the data on your Docker host. Okay, to if you want to save your data, if you want to persist your data, you can use this concept of volumes, and it's going to store your data in this location. Else it is going to get terminated by default. This is a default behavior. Okay, so this is how Docker volume works. Okay, now if I want to show you, so let me show it to you on a terminal how this thing will actually look when we do a demo. So I'm on my terminal now, and let's see what all Docker images we have. So I'm going to use this particular image which I have, which is Apache 2 Tech. So this is actually Apache web server. Okay, so this image is going to when I create a container out of this image, it's going to create a Apache 2 based web server on this Ubuntu machine. This is the Ubuntu machine. So my Docker host is Ubuntu 24.04 LTS operating system. So let's run the same command which I showed you in the diagram. Okay, so I'm going to run the same command, and we'll see what will happen, how the data is will be persisted. Okay, so docker run -d in detached mode -p for port mapping. So I'm going to use 8081 for this demo, and I'm going to map my 8081 port on the host to 80 port inside the container, since I know Apache 2 runs on port 80 by default. Okay, so if I don't make any changes to this container, it's going to run on port 80 inside the container, this web server container. Then I'm going to specify -v, and I'm going to create this volume 1, right? Volume 1 it is, and I'm going to map this to a directory inside the container. So I'm going to use the default directory from where this Apache web server serves the content on the website, which is /var/www/html directory. Then I'm going to use the image name. Okay, and let's try to create this container. All right, so I got this long ID, which means the container was created. I can see the container is up. Okay, so let's just see how we can persist the data. So let me just exec into this container. So I'm going to do docker exec. So I'm going to log in to this running container. I'm going to attach an interactive terminal -it space then container ID, and I'm going to use my shell sh. I'm inside the container now. So okay, so now if I do ls here, I can see all the file system directories which are there by default, but I'm inside /directory, root directory, but we have mapped our volume 1 on the Docker host to /var/www/html inside the container. So let's go to this directory now. So I'll cd into this. So I'm under /var/www/html, and if I do ls, I will see one index.html file already present, because when I created this Docker image, Apache 2 Tech, I copied a file index.html into the Docker image. So when I created the container from this image, I have this file already copied to my container layer in the container. Okay, so this file is there by default. Okay, now I have logged into my Docker host on another on another terminal to show you something. So we just ran this command, and we have created this volume 1. Okay, so as I mentioned in the diagram, this volume 1 will be created under this directory. Okay, so we will just navigate to this directory to see if this data is present on this directory also. Here we have this index.html file. So this same file should be located on this directory on the Docker host also. Okay, that is what the meaning of this -v flag here. So I'll just navigate to that directory. So it's /var/lib/docker/volumes, and if I do ls here, sorry, ls, so I can see this volume1 directory which is created. Okay, so let me log into this volume1 directory, and if I do ls here, I will see that same file. Sorry, I need to go to this /data directory once. So under /data, I will see index.html file. Okay, if I cat this file here inside the container index.html, so the only text present is success. Okay, similarly, if I cat the content here, it's going to be the same, success, right? Now if I make any changes inside the container, for example, I want to change the content of this file, so let me echo something else. Echo, let's just type something else, and I'm going to redirect it to index.html, right? If I cat the file again, index.html, I will see something else, right? So I made the change inside the container, right? But I know that even though it seems that I'm making changes to the file inside the container, but this data actually resides on my Docker host. So whatever changes you make here, it's going to be made on this directory, okay, under this directory. So to verify that, if I do cat on the file, you can see the data is changed immediately because you're making changes here, but the data is actually changing in this location. Okay, so this is the concept of Docker volume. So even though this container gets deleted or terminated, I will have my data backed up on this location. Okay, now another thing is, if you make any changes to the files, or if you make any changes to the files or directories under this volume section here, it's going to reflect inside the container also. So it is, it's going to work both ways. Okay, so if I create a file here, for example, if I create a file called file1, touch file1. So I have two files now, index.html and file1, and this file I've created on my Docker host. I did not log into the container, but I just went to the directory where I have mapped my volume inside the container on Docker host, and I created this file called file1. Okay, and if I did ls, I can see the new file. So now if I go here on this terminal where I've logged into the container, if I do ls here, I will see the same file here also, file1. Okay, similarly, if you create another file, file2, do ls here, you will see that same file here also. So you see how the data is being created. So it is actually created on my Docker host and not inside the container. So this is the concept of volume. Okay, if I delete any files here, it's going to be deleted there. So let's just delete file1. File1 deleted. So only only file2 and index.html are left. And if I do ls here, you can see only file2 and index.html is left. File1 is deleted. Okay, so this is how Docker volume works. I hope the concept is clear to you. Okay, now another thing I want to show you. Let me just come out of it. So this is the Docker container. Now if I delete the Docker container, so I'll do docker rm space -f for doing it forcefully, because the container is running and I did not stop it. So I have to use -f flag here. So I deleted the container. Okay, but if I do ls here, I will have my data as it is, right? Now if I create the container again with that same volume, so I can just repeat the command. Okay, let's see if this container still is there. It's not there, right? Even if I use all flag, it's not there. So the container has been terminated completely, but the data is still there on the Docker host. Okay, now if I repeat the same command, okay, let me just give it a name also. So let's name this container as wall container. Wall container. Okay, so I'm trying to create this container again, and again I'm using the same volume. So whatever volume is, whatever data is inside this volume, it's going to be mapped inside the container. Done. So the container is up, created 4 seconds ago, up 4 seconds, right? And this is the name. So once again, if I map, once again, if I just exec into this container, exec-it, container ID, sh, and I'll just navigate to the directory where I've mapped my volume, which is /var/www/html. If I do ls here, you will see the same files, file2 and index.html already present in the container, because this is coming again from this directory here on my Docker host. Okay, so this is how you are able to persist the data on your container. So I deleted the container, earlier container, and whatever data was generated by that container, it's still there in the same location, because the data is residing on my Docker host now and not inside the container. So this is the concept of volume. Okay, I hope it is clear to you now how we can have a data persistent inside a Docker container. Now let's talk about the different type of volumes available in Docker. So we have 4 types of volumes, or we can say storage mounts, available in Docker. The one that we just saw in the example, that is called volume mounts, and this was the command that we ran, right? So you can use -v or --volume. It's the same thing. Okay, so the main difference between volume mount and bind mount, it is actually a very important question to understand. In volume mount, whatever volume name you are giving in your host path, if that volume is not present already on your Docker host, which means that volume does not exist, then Docker daemon is going to create it for you and manage it for you as well. So we don't have to create this volume before we use it in our Docker run command. Okay, but with bind mount, what we do, we specify the directory on the Docker host where we want to persist the data from the container. So that is mentioned in the source field here. Okay, so this source is equal to host path is where we have to define the absolute path to the directory where we want to persist the data from inside of the container. Okay, and that particular directory should already exist before you use it in your Docker run command. If that directory does not exist, then this command is going to fail. So let's see an example of bind mount. So I'm on my terminal here, and if you see, this is the format of a bind mount that you have to use. So let me just copy and paste. So this is the command. It is in the same format that is given in the PPT here. Okay, so this is the command format that you have to use for bind mount volumes. Okay, and let me just explain this for you. So Docker run -d for detached mode, -- name is the name of the container, then -p for publishing ports, or we can say port mapping, and then for bind mount you use a flag called --mount, and then you have to specify what type of volume you want to use. So here I want to use the bind mount, so you have to use type is equal to bind, and then source is the absolute path to the directory on the host which you want to use to persist data inside the container. So here I'm using /root/vol. Then DST stands for destination, is where you want to map this volume inside the container. So I'm using /var/www/html because I'm using this Apache 2 web server, and I'm using this Apache 2 tech image which I used in my previous example also. Okay, so just before I run this command, I want to show you something. So I am under /root. Okay, and I'm using a path /root/vol. But if you just check, if you just list out the contents of this directory, you will not see this particular path available. Okay, so /root/vol does not exist at the moment. Okay, and I'm still trying to mount it, and I'm trying to create a container by using that that path on my Docker host. Okay, so if I run this command now, so this is the type of error that you're going to see. Okay, Docker error response from daemon, invalid mount config for type bind source path does not exist. So this is the difference between a bind mount and a volume mount. In case of volume mount, I did not have to create the volume before I used it in my Docker run command. So Docker creates it for you automatically. Okay, and Docker also recommends to use volume mount instead of bind mount. Okay, I mean wherever possible. So now if I just create this path, so let me create this directory mkdir vol. Now if I list out, I have this /root/vol available, and now if I run that same command, it's going to work. Okay, so I have a running container. Okay, and the volume has been mounted in /vol. So what we can do is, let me just exec to it. So docker exec -it container id, and I'll do sh. I'm inside the Docker container now, and I will just navigate to /var/www/html. If I do ls, I don't see the file because I have mounted this particular path on my host. Okay, so whatever files are present in /root/vol, only those files will be available here. Okay, so you won't see that. So whatever you create here, for example, if I create a file called touch t1, just any random name, ls, file is there, right? Now let me just log out of the container, and let me go to vol directory, and if I do ls, I will see the same file here. But now if I create any file here, for example, I do touch file ls, so I have this new file. I'll log into the container again. And now if I go to /var/www/html, do ls, I will see the same file and t. So whatever data is there in your mapped directory on the Docker host, okay, that same data will be available inside the container. Okay, so this is the main concept of volumes. Okay, so I mean, in this way you can persist the data on your Docker host to inside the container. Okay, I hope the concept is clear to you. Next, I want to talk about another type of volume which is called tmpfs. tmpfs it literally stands for a temporary file system. So a temporary file system is temporary and only persisted in the host memory. When the container stops, the tmpfs mount is removed and the files written there won't be persisted. So sometimes you may have a use case wherein you don't want to write the data to the disk, but you still want to keep it in the Docker host's memory. So in that case, you can use this tmpfs. Okay, we don't generally use it. Okay, I mean, only some specific use cases there. Only, I mean, that will be the time when we'll be using this, but you should know that this type of volume exists. Okay, and these are the two type of commands that you can use to create your tmpfs volume. Then if I talk about another one, the last one, it's called named pipes. So it is used for communication between the Docker host and a container. And the a common use case is to run a third-party tool inside of a container and connect to the Docker Engine API using a named pipe. Frankly speaking, I haven't used it as of now, but but once again, you should know that this type of volume do exist. Okay, if we have a specific use case which matches this, like we have a third-party tool that we have to run inside of the container, and we have to connect it to the Docker Engine API. So in that case, we can use this named pipe. But as I mentioned, I haven't used it. Okay. So these are the 4 type of volumes that are available in Docker. I hope the concepts of all the 4 are clear to you. If you have any doubts, please reach out to me in the comment section. Now, let's talk about networking in Docker. But before I talk about that, I want to talk about how 2 containers running on a single Docker host are isolated from each other. So the 2 Docker containers running on a single Docker host have a separate file system, completely isolated from each other. The processes running in one container is going to be isolated from other container. The resources that the 2 containers are using of the Docker host are going to be isolated from each other. And in terms of a network segment, the 2 containers will have their own separate unique IP addresses assigned to them. So this is the default behavior of 2 containers running on a single Docker host. Okay, so these are the type of isolations that we are talking about. But how these containers are getting this type of isolation? Which process or which mechanism is responsible of getting this isolation between the 2 containers running on a single Docker host? This happens with using the concept of namespaces. So we have various namespaces by which we can create this type of isolation between 2 containers running on a single Docker host. Okay, so I will try to do a video on namespaces where I will be talking about the different namespaces that are available in much more detail. But for now, just understand that this isolation happens using namespaces. All right, now let's come back to our networking concept in Docker. So even though we just spoke about how the 2 containers are isolated from each other, even then one container can actually communicate to other container by default on running on a single Docker host. So if you have 2 containers running on a single Docker host, one container can actually communicate with other container. And this happens using the default networking driver in Docker that is called bridge. As you can see on my screen, bridge is the default networking driver. So when you are creating any container using Docker run command, and if you do not specify any networking driver, so the default networking driver which gets installed when you install Docker is going to be used with each of your container that you are running on a Docker host. Okay, and the main use of this default networking driver bridge is to ensure that one container can communicate to other container. So this is the default networking behavior in Docker. So I also have a diagram to show you. So just concentrate on Docker host 1 here in this diagram, and this is how the bridge networking works. So we have 2 containers running on a single Docker host, and this container can communicate with this container, and this container can communicate with this container, because these containers are on same network, which is bridge network, which is the default networking driver in Docker. Okay, but as you can see on my screen, apart from bridge networking driver, which is the default one, we also have other networking drivers which decide how the networking is going to be configured between your containers and from your containers to other non-container processes also running on a Docker host. Okay, so let's talk about these different networking drivers in theory first, and then I'm going to show you a demo on my terminal. So bridge is the default network driver. Apart from that, you also have host, which is to remove network isolation between the container and the Docker host. So whenever you are trying to create any container, and if you specify the networking driver as host while running the while trying to create the container, then what's going to happen? Your container is going to have the same host name as your Docker host. So there will be no isolation between their networking environments. Okay, so host network will be assigned to your container also. The meaning of this host network. Then you have none networking driver, which means that you are completely isolating a container from host and other containers, which means that if you create a container with none networking driver, that container will not have any networking configured. Okay, so that container cannot talk to other containers or to any process running on the Docker host. Then we have overlay networks. Overlay networks connect multiple Docker daemons together. It means that if you have multiple Docker hosts, okay, so till now we have only spoken about one single Docker host where we have Docker installed, but there are cases wherein you can have multiple Docker hosts configured and there will be multiple containers running on these Docker hosts. So if you want one container running on one Docker host to be able to communicate with other container running on another Docker host, then the default networking that you need is overlay networking. So you need overlay networking driver so that one container from one Docker host can talk to other container running on another Docker host. Okay, I will talk about this in much more detail once again in a separate video where I will be talking about Docker Swarm. So Docker Swarm is the container orchestration available in Docker. Okay, we don't talk about it much because Kubernetes has taken over, and Kubernetes is still the standard for container orchestration, but we do have a Docker Swarm, and in some use cases you can actually use Docker Swarm. Okay, so I will talk about it in another video where I will cover all the concepts of Docker Swarm. So if I can show you in a diagram how overlay network looks. So here we have two Docker hosts, Docker host 1 and Docker host 2. And if, for example, container 2 on Docker host 1 wants to talk to container 3 on Docker host 2. Okay, similarly, if container 3 on Docker host 2 wants to talk to container 2 on Docker host 1, then this type of networking is possible using overlay networking. Okay, where we have multiple Docker hosts and one container on one Docker host wants to talk to other container on another Docker host. Okay, this is how it looks. All right, apart from these four, you also have ipvlan. ipvlan networks is actually used wherein you want to have separate unique IP addresses to all your containers, but the MAC address of the host can be used with all of these different containers. So it means that your containers are going to have the separate unique IP addresses, but they can still be referred with the same MAC address of the Docker host. So once again, there are some specific use cases where we can use ipvlan. Okay, so yeah. Then the last one is macvlan. So macvlan is to assign a MAC address to a container. So this is used whenever we have the requirement of treating one container as a separate physical device. Okay, you want a different MAC address for each of your container running on a Docker host. So in that case, you can use macvlan networking driver, which is going to assign a separate MAC address to each of your container. Once again, some specific use cases do use macvlan networking drivers. All right, so this is about the theory part of Docker networking driver. Now let's take a look at some of the demos related to networking. So I will go to my terminal and show you some demos related to networking so that you understand how it actually looks in real time. So I'm on my terminal logged in as root, and let's just take a look at the default network or default networking configuration that we have available when we install Docker on any machine. So you can use Docker network ls to see the default networking drivers which are configured. Okay, so I haven't done anything. I just installed Docker and I have 3 networking drivers already configured on my machine. Okay, so the default one, as I mentioned, is the bridge one. So when you create any Docker using docker run command, and if you don't specify any networking configuration or networking flags, in that case, this bridge networking is going to be used for all Docker containers. So to inspect this Docker container, what you can do is docker inspect and this network ID, and you can see all the details of this networking driver. Okay, so what I want to show you here is this thing, com.docker.network.bridge.name. So this networking driver has a name that is called Docker 0. So a Docker 0 is the name of the networking interface that Docker creates when you install Docker, and it uses bridge networking. Okay, also if you see some of the other details here, like if I talk about this subnet one, so subnet of this networking driver is 172.17.0.0/16, which means that any new Docker container that will be created and that will be using this networking driver will get an IP address from this subnet, and this is the gateway ID. So 172.17.0.1 is your gateway. So the first IP that will be assigned to any Docker container using bridge networking will be 172.17.0.2. Okay, the meaning of this, because this first IP has been assigned to the gateway. So the first IP that is free is 172.17.0.2. Okay, so this is how this IP actually works. This is how this IPv4 addressing works with the default networking driver bridge. Okay, so now if I just show you, we just saw the name of this networking driver. It's called Docker 0. And if I want to check all the networking interfaces on my machine right now, I can run a command called IP space A. It's going to show me all the networking interface that are currently configured. So you can see this Docker 0 is already installed and configured. Okay, and so this is the one that we just saw related to this command that we used for inspecting this bridge networking driver. So it is using this Docker 0 networking interface. Okay, now let's try to create some containers and see the networking that is configured by default. So I'll just see what all images I have. So let's use any image. We can use this image, Apache 2 Tech. So I'll do docker run -d for detached and -p for port mapping. Let's use 8081 as the port on my host, and I'm going to map it to port 80 inside the container, because I know Apache 2 web server runs on port 80 by default inside the container. So done, and then the name of the image. Container created. We do docker ps. The container is running up 4 seconds. Okay, so let's just inspect this container and see the networking configuration that is there. So if you see in this command, I did not configure any networking here, right? So it's going to use the default networking that is configured for all Docker containers. So we can do docker inspect container ID to see all the information related to this Docker containers configuration. So if you scroll here, so you can see the IP address 172.17.0.3. okay, is the IP address, because I already have a few containers running on this machine. So the first IP has already been utilized there. So I'm using 172.17.0.3. okay, and if I talk about some other information especially related to networking, so you can see all the details here. Okay, the one that I'm interested in is network mode. So actually you can filter it out. So when you run this command docker inspect, you can just filter out the network mode that is configured on this Docker container. So you can use this pipe command with grep, and you can just type network mode like this, and it's going to show you the network mode that this particular container is using. So it's using bridge networking. Okay, because I did not configure any networking, so it is bridge, which is the default one. This is how you can check. This is fine. And we also saw Docker network ls. So these are the three type of networking that is available. Okay, so what I'm going to do now is I'm going to create another Docker container. Okay, and then from that Docker container we will try to ping this container to see if one container is able to ping the other container or not. Okay, so before I do that, I want to show you what all containers are running. So we have three containers running here. Okay, and if I try to inspect each of these Docker containers, like Docker inspect, let's start with this one. So in this, if you see, there's one IP address assigned, 172.17.02. So this is the first IP from that subnet of Docker 0 bridge networking driver. So that is assigned to this particular Docker container. Okay, but we do have other container also. If I do Docker ps, you can see there is another container which is already running, which is this one. So if I do Docker inspect on this one, so for some reason this does not have any IP address assigned. Okay, so there's no IP address assigned to this particular Docker container. Okay, so that is why you will see when we created the new container, it got 172.17.0.3. So all I'm saying is it's going to be in the sequence. So whatever subnet is available with your networking driver, that networking driver is going to assign the different IP addresses to these containers in sequence. So it's going to start with 172.17.0.2 because 172.17.0.1 is the gateway IP. Okay, so this one has 0.1 as the IP. This does not have any IP assigned, and this has 0.3 as we just saw. So let's just check that again. So this is how IP addressing works in Docker by default. Okay, so it has 172.17.0.3. Okay, I hope this is clear to you. Now let's try to create another container. So I'll just use that same command, and I'll just give it a name so that we are able to identify that this is different. So let's just write bridgecon, and also I have to change the port. So I'll use 8082. Done. Now we have this container also. So we have 4 containers. Okay. So if I just, so these 2 containers are the one that we just created. So if I just log into any of these 2 containers and try to ping the other container, since these 2 containers are using the default networking driver bridge, we should be able to ping the other container. Okay, that's what I want to test. So I'll just go to any of the containers. So I'll do docker exec -it, and I will choose this container here, and I'll use my sh shell. I'm inside the container. So what I can do is, first I have to identify the IP address of the other container. So this one. So I think this is using 172.17.0.3. So if I do ping, then I'll just copy this IP address. Okay, ping is not installed inside the container. So let's install that. So I know that it uses Ubuntu. So I'll do apt install. I believe it's called inet utils -ping. So this is the name of the package which gives you ping command. Yep. So inet utils -ping. So after I do that, I can do ping and that same IP address. And you can see I'm able to ping the other container 172.17.0.3. Okay, which means that the bridge networking is working. Okay, this is done. Now what I'll do is I will create another container. Let me get rid of the other containers to avoid any confusion. So I'll do docker rm -f. Let's just delete these two. These two are deleted. So we have two containers only, and they both have bridge networking configured, right? And we just saw that how we are able to communicate to other container from one container using the ping command. Now, if I create another container, but this time I'm going to change its networking. So let's use the name as hostcon. Okay. And I'm going to, let's use 8083. Actually, port configuration is not required when you are using host networking, because the same networking is going to be assigned to your container, which means that there is no network isolation between your Docker host and your Docker container. So you don't need to specify any port mapping, so you can get rid of it. So I want to use the host networking now. Okay. So I'll do D, and I will specify network as host. Okay, I'm talking about the other one. So we just saw this bridge networking. Now I want to show you this host networking. Container created. Now let's just inspect this container straight away. So docker inspect this one. Okay, and this is the host name of my machine here. As you can see, this is the host name of my machine where I've installed Docker. Okay, now if I do docker inspect this, and go up and see the host name, you can see it's the same host name. Okay, it's the same host name. Also, if I do curl localhost, I can see this. Okay, so this is coming from the container, because since container and my Docker host are using the same network, so it is like running this on my local host. Okay, but this is actually running inside the container. Okay, but since we have host networking enabled, so there's no networking isolation between my Docker host and my Docker container. So whatever is served within the container, I can access all that on my Docker host using localhost. Okay, so this is how host networking works. I hope the concept is clear to you. Okay, this is fine. Now what we will do, we will create our own network. Okay, we just have 3 networks available with us, so we are going to create our own network now. So we'll do docker network create, then name of the network we can use net1 probably. So when you are trying to create the network once again, okay, and if you don't specify any networking driver, so it's going to use bridge networking by default, which means that this particular network is going to have bridge networking enabled. Okay, network created. Now if I do docker network ls, I will see this new network also created, which is net1, and you can see the driver is bridge, because I did not specify any networking driver while trying to create this Docker network, so it's going to use bridge by default. Okay, now what I'm going to do is, let me just see what all containers are there, and let me get rid of one of the containers. So docker rm -f for forcefully doing it. I will get rid of this one. So now we have just one container running, and it has bridge networking enabled, right? With the default bridge network. Now, if I create another container, so I'm trying to create another container, and this time the network will be my network. So once again, even though you have 2 networks here with bridge networking driver, okay, but if I change my network to my new network, okay, so in that case, the other container which is using the default bridge network will not be able to communicate to any container which is using net1 networking driver, because so this is the default behavior. Once again, if you create your own network and use that to create the container, you have specified that new networking with your new Docker container, that Docker container will not be able to talk to any other container outside of that network. Okay, so here if I do net1, so what I'm specifying, I want to change the networking configuration. So I'm using my own network that I just created to create this container. Okay, and I can use net1 con, probably net1 con. Okay, and I'm going to use port mapping as well, because I'm not using host network. So let's do 8081 to 80. Done. Now we have two containers running. Okay, so once again, let me repeat myself. So this container here, this one, is using the default networking driver of Docker, which is bridge, okay, with this network ID, right? But I created my own network called net1, and I use this new network with my new container here while trying to create it with this one here. So this container is now using a different network than the bridge network. So by default, there is a network isolation between two networks. Okay, so if I try to ping this particular Docker container from the previously created Docker container, then there will be no networking enabled. Okay, so to test that, what I'm going to do is I'm going to exec into the earlier created container. So I'll do docker exec -it. Okay, and okay, just before this, I should know the IP address of the newly created container with my own network. So I'll just come out of it and do docker inspect on the new container, which is this one, right? So this container is using my own default network that I just created, net1. So as you can see, the IP address is also different. Okay, it is using a separate IP address subnet, you can say, because since this network is a new network, so it has its own subnet assigned to it. Okay, so it's using 172.18 series. Okay, so this is the IP address here. Fine. So what I'll do is I'll exec into the previously created container, and I'll try to ping this IP address, and you can see it's not going to work because this network this container is in a different network than the other container, so there is no networking enabled. Fine. But now if I create any other container, if I create a new container, for example, and if I use port number 8083, so I'm trying to create another container using my own networking driver that I used, that I created. Okay, this net1, this one, net1. So let me create another one, and here the name will be net2con probably. Done. Now if I do docker ps, and if I log into my first container that I created with my own network, which is this one, so I'll do docker exec -it. Okay, one more thing before that, let me just find out the IP address of the newly created container. So this is the newly created container with my net1 network. So I'll do docker inspect on this one to identify its IP address. So it is 172.18.0.3. Fine. So now I will log in. I will exec into my other other Docker container which is using my net1 networking driver. Okay, so docker exec-it, this is the one. And from here, I will try to ping this IP address, which is also in the same network, net1, right? So we should be able to, this Docker container should be able to communicate with this container. Okay. Ping is not installed, so once again I have to do apt install inet utils -ping installed. So now I will do ping and that same IP address, which is this one. And this time you can see I'm able to communicate to this container. So this is how networking works. So if you create your own container, and if you create your own network and you specify that network while trying to get the container, so any other container that is in that same network will be able to communicate to that. If you have, if you're trying to communicate one container on one network to another container in another network, in that case networking does not work. So this is the type of network isolation that we have in Docker container. I hope the concept of bridge and host is clear to you. Okay. Similarly, you can use none to have all the networking disabled for any container. Okay, so while trying to get the container, if you specify this network as none, like this, and if I just name it as okay, so now if I do docker inspect on this container where I'm using none network, you don't have to copy and paste the entire ID. You can just copy and paste the first few random ID from your Docker container ID, and it's going to work because it should be unique. Whatever you have copied here, it should be unique from other containers. Okay, so only these few numbers you have to copy. You don't have to copy the entire container ID. Okay. If I do now, we can see IP address is none. Also, if you check the networks, it is set to none, which means that this particular container here, the newest container, has no networking enabled. Okay, no ports, nothing, because it's using none networking, which means that this is completely isolated from the Docker host and from other containers running on this Docker host. So this is how container networking works. Okay, I hope the concept is clear to you. Okay, so this is how bridge networking works. Okay, so you can create your own container, and you can get your own network and then use it with your new Docker containers. Okay, to have a separate networking enabled for your containers. So this is another way of getting isolation from your containers from other containers running on the same Docker host. Okay, similarly we have this overlay network also, which I will cover in another video where I will be talking about Docker Swarm, how Docker works in Swarm mode. Okay, so there I will talk about this overlay networking when we have multiple Docker hosts. Okay, and that's all I wanted to cover in this video. Okay, so these are the 4 type of networks actually which you should be concerned about, and these 4 are the ones that I use the most, and also you will get a lot of interview questions also on these 4 networking drivers. Okay, so that's all I wanted to cover in this video in terms of Docker storage and Docker networking. I hope all the concepts are clear to you. If you think you did not understand anything or anything was confusing, okay, you can always reach out to me and I'm going to answer all your queries. All right, guys, I'm going to see you in the next one. Bye for now.